Hello everyone, I'm Mula Venkata Reddy. Today we will dive deep into Azure Storage, understand its architecture, real-world usage, and most importantly, the advantages and disadvantages you should know as developers, architects, and cloud learners. This architecture is perfect for modern distributed applications, microservices, media platforms, IoT workloads, and enterprise migrations. Advantages of Azure Storage: 1. Fully managed service. No infra headaches. Azure Storage is fully managed. You don't need to handle servers, hardware failures, disk provisioning, or storage scaling. Azure automatically takes care of maintenance, patches, upgrades, replication, and availability. For development teams, this means faster delivery, less DevOps overhead, and no physical failures to troubleshoot. 2. Massive scalability. KB to petabytes. Azure Storage can scale from storing small files to petabyte-scale data. Whether 100 users upload files or 1 million users upload videos, Azure scales automatically without manual intervention. This is extremely useful for apps like YouTube-style media platforms, e-learning portals, OTT services, analytics systems, and backup engines. 3. 11.9's durability. 99.999999999%. Azure ensures 11.9's durability by replicating your data across multiple disks, zones, or even regions. Supported redundancy options include LRS, local replication within a region, ZRS, across availability zones, GRS, across paired regions, RAGRS, read access even if region fails. This protects your data from hardware failures, zone outages, or entire regional disasters. 4. Global access via HTTPS. Your data can be accessed from anywhere over HTTPS using APIs, storage SDKs, or CDN integrations. This enables global content delivery, browser access, mobile app streaming, API downloads, cross-region application access. No need to deploy storage per country. Azure handles global reach. 5. Enterprise-grade security. Azure Storage supports 256-bit AES encryption, at-rest HTTPS encryption, in-transit Azure AD-based IAM RBAC roles, instead of sharing keys. Managed identity. No secrets in code, key vault integration, and automatic key rotation. This ensures identity-based secure access, not key-based access, which reduces security leaks. 6. Async communication using queues. Queue storage makes your architecture decoupled and fault-tolerant. Instead of services waiting for each other, tasks are placed into queues and processed by workers later. This gives higher reliability, better performance, background job isolation, retry safety, service independence. It also matches the microservice best practices you follow as a .NET Cloud developer. 7. Fast metadata lookup using NoSQL tables. Azure Table Storage provides ultra-fast key-based lookups using partition key plus row key architecture. This is ideal for storing video metadata, processing status, user activity logs, thumbnail links, IoT device state, job tracking records. No complex schema, no joins, just fast retrieval. 8. Cost-efficient storage tiers. Azure offers hot tier, frequently accessed data, cool tier, rarely accessed data, archive tier, long-term backups and logs. You can also apply lifecycle rules to auto-move data from hot, cool, archive, delete. This dramatically reduces storage costs. 9. Multi-server shared access using Azure Files. File storage supports multiple servers mounting the same folder using SMB/NFS. This helps in lift and shift migrations, legacy apps, multiple app servers needing shared folder access, VM workloads, corporate shared upload directories. This avoids building custom file sync solutions. 10. Supports any data type. Azure Storage can store text, images, audio, videos, logs, backups, app, data, IoT, telemetry, static website assets, temporary background job messages, a true 360 degrees storage backbone. Disadvantages of Azure Storage. 1. No internet, no access. Azure Storage is a cloud service, so without internet, your data is not accessible. For applications running in isolated offline environments, this becomes a limitation. 2. Costs can increase if mismanaged, even though storage is pay-as-you-go. If lifecycle rules are not configured, logs are not archived, old blobs are not cleaned, replication is over-provisioned, then costs can increase quickly. Cloud storage needs governance, monitoring, and automation. 3. NoSQL joins in table storage. Azure Table Storage is NoSQL, so you cannot run SQL queries. Join tables, apply foreign keys, enforce schema. This can be a limitation when relational querying is required. 4. Vendor lock-in risk. Once your system deeply integrates with blob SDKs, Azure file mounts, queue triggers, table keys, event grid, migrating to another cloud provider may require architectural refactoring. 5. Limited querying compared to Cosmos DB. While table storage is fast, it has limited query capabilities compared to more advanced NoSQL databases like Cosmos DB. You can filter by keys, but complex queries are harder. 6. Requires proper IAM and key rotation discipline. Although Azure offers security, teams must correctly implement managed identity, RBAC, key vault integration, storage key rotation. If not done properly, it can still lead to security risks. 7. Not ideal for ultra-low latency local disk needs. Since data is remote, it may not suit high-frequency disk read/write systems, local caching heavy workloads, real-time media editing. Without CDN or cache, without proper caching layers, performance can vary. 8. File share performance depends on protocol and region. Azure Files uses SMB/NFS, which may not always match the performance of a local SSD or NVMe disk, especially across distant regions. Eventual consistency in some scenarios, depending on replication type and access pattern. Some services may show slight delays in updates, especially in geo-redundant storage. 10. Debugging distributed pipelines can be complex since architecture is decoupled. Uploads trigger events, queues hold tasks, workers process jobs, metadata updates separately. Tracing failures across services may require good logging and monitoring strategy using app insights, storage logs, or custom tracing. Best practices to avoid disadvantages. To overcome these limitations, always implement lifecycle management rules to auto-archive and delete old blobs. Azure AD+, managed identity, to avoid storing secrets in code. CDN, caching to reduce latency and improve global access speed. Monitoring and alerting using Azure Monitor or App Insights. Replication, based on actual need. Not maximum possible queue workers with retries for reliability. Proper partition key design for hot data distribution. Key rotation. Using Key Vault. Use Cosmos DB if advanced NoSQL queries are required. Local caching, where frequent access is needed. Final summary for the lecture. Azure Storage provides blob storage for large unstructured files, file shares for multi-server shared folders, queues for async job messaging, tables for fast NoSQL metadata lookups. Its biggest strengths are scalability, durability, global access, security, cost efficiency, and seamless .NET integration. Its main limitations are internet dependency, NoSQL query limits, potential cost increase if mismanaged, vendor lock-in, and distributed tracing complexity. But with good architecture practices, automation, IAM discipline, caching, and monitoring, Azure Storage becomes one of the most reliable cloud storage foundations for modern .NET developers and enterprise systems. Thank you for attending this lecture. This is Conda Reddy, signing off. Keep learning cloud architecture.